We are going to talk about Airflow and Bigtop. I'm Masatake, a committer of Apache Hadoop and Apache Bigtop. And he's Kengo, a committer of Apache Airflow and Apache Bigtop. We are working for NTT Data in Japan as software engineers. NTT is ex-national telco companies in Japan, and NTT Data is system integrator. And we are providing professional services around open source products used in the systems of our customers. Today, I'm going to introduce Bigtop first. Then Kengo will talk about Airflow as a workflow engine in the Bigtop stack. First, what is Apache Bigtop? Bigtop is an ASF project for data engineers looking for packaging, testing, and provisioning open source big data components. Bigtop is open source Hadoop distribution providing working combination of versions of products. Bigtop provides scripts, configurations, and patches to build components as native packages on widely used Linux distributions. Bigtop provides automated deployment of cluster based on the Bigtop packages. Bigtop provides smoke tests for products in the stack. Bigtop also provides local cluster provisioning using containers for your development and testing. Apache Bigtop is based on the code donated from Cloudera to ASF in 2011. The word big data was a buzzword in the era. It became the top-level project of ASF in 2012. And Bigtop 1.0.0 was released in 2015. The Bigtop 1.x was based on Hadoop 2, and Bigtop 1.5.0 was the last release in the series of 1.x. We skipped Bigtop 2 because the word Bigtop 2.0 was used for internal experimental project. So we released the first stack based on Hadoop 3 as Bigtop 3 in 2021. We dropped retired projects including Uzi from the stack on releasing Bigtop 3.3.0 in 2024. And the Uzi was workflow engine previously used in the Hadoop distribution. Then we added Airflow as a new workflow engine to the stack on Bigtop 3.5.0, released in the last month. We'd like to introduce each features of Bigtop here. Again, Bigtop provides packaging and provisioning and tests. Bigtop provides staffs for building RPMs and devs on supported Linux distributions. At first, you can install required toolchain, including compilers and libraries, by Puppet. Installing toolchains takes a lot of time because it installs all tools needed for building all products in the stack, including Hadoop and Spark. Packages built by running -pkg task. So Airflow -pkg task means building Airflow package. If you want to build Spark packages, you should run Spark-pkg task too. And repo task creates package repository based on build package. If you run these tasks on Rocky Linux 9, RPMs for Rocky Linux 9 was created and YAM repositories are built. If you run the tasks on Ubuntu Noble, it creates dev packages for Ubuntu Noble and apt repository. You can also do the packaging inside provided containers with pre-installed toolchains. You can build RPM packages on Debian variant hostOS by this, and you can build dev packages on Red Hat variant hostOS. You can also install products in the Bigtop stack using pre-built packages from published repositories. You'll need to install GPG keys for verifying package signatures. This slide shows the example of installing RPMs on Rocky Linux 9. You can install dev packages on Ubuntu almost the same way. Instead of just installing packages manually, you can provision cluster by using Puppet manifests provided by Bigtop. Puppet itself can be installed by the script in the Bigtop toolchain. And this slide shows the example of provisioning Rocky Linux 9 cluster. And this is the example of deployment of cluster by Puppet on Ubuntu. The URL of repository and module path of Puppet slightly differs based on OS environment. Then you can run smoke tests of products on provisioned cluster by running test-related Gradle tasks. It usually runs sample jobs against provisioned cluster. The test cases are not so rich now, especially for recently added products like Airflow, so we need to improve this. Bigtop provides Docker provisioner for provisioning cluster by Puppet manifest, then running smoke tests inside the containers. You can leverage this for local testing of packaging and deployment. You can do interactive try and error inside the provisioned container.
Thank you, Masatake, for introducing Bigtop. From here, I will explain why we adopted Airflow as a new workflow orchestrator and how it is integrated with other products in the Bigtop stack. There are mainly three reasons why we chose Airflow. First, Airflow is de facto standard of existing workflow orchestrator. So from user's perspective, if we choose Airflow, they can easily move to or move from other various SaaS or managed services such as Astro, MWAA, Cloud Composer, and so on. The second reason is that Airflow is so widespread that we can easily find information or solution on the web, and AI chatbot also gives us the right answer in most cases thanks to a vast amount of such information. In addition, Airflow developer community provides awesome documents, actively adds new features as mentioned in keynotes, and they aggressively addresses bugs, so we can expect its steady improvement. The last reason is affinity with the existing Bigtop software stack. I'll explain it in the next slide. As Masatake already mentioned, Bigtop is composed of various products developed in ASF, such as Hadoop, Spark, Flink, and Kafka, and Ruby. Working with these components from scratch is a bit tough, but as you know, Airflow offers a wide range of off-the-shelf provider packages for interacting external systems, so they can be easily integrated by using Airflow. In addition, Airflow has several enterprise-grade features. For example, Hadoop requires Kerberos to achieve strict security because it is easy to pretend who you are by default. And some workflow engine has difficulty working with Kerberos, but Airflow natively supports it, and it can renew Kerberos ticket automatically and periodically. Also, these Bigtop components can be deployed to a large cluster due to its nature of big data processing, and it is proved that Airflow has enough scalability for such heavy workloads, as mentioned in a lot of sessions in this event. As the final part of this presentation, let me show an integration example of Bigtop Airflow and the existing Bigtop software stack. Bigtop has a sample application called BigPet Store, including ETL, data analytics, and machine learning. It is based on Hadoop's HDFS, Yarn, and Spark. The pipeline mainly consists of 4 tasks. To be precise, there is 2 more tasks before them, but they are just cleanup tasks, so I'll omit them. The first task generates fake sales transaction data of fictional pet stores. The generated data is not normalized yet, and all of information is packed into a single row. So the second task performs ETL and separate that data into corresponding tables. Using these normalized tables, the task above executes the very basic data analysis, such as counting the number of transactions by months or products. The last one below is a machine learning task. It runs product recommendation for each user using collaborative filtering with ALS algorithm. To demonstrate this pipeline, I'll show an example deployment to a cluster with a single head and multiple workers by using Bigtop. We'll deploy Airflow, name node, resource manager, Spark Zeppelin to the head node, and data node and name node to the worker nodes. Apache Zeppelin is notebook software developed under ASF and not mandatory here, but it's useful to analyze and visualize data interactively, just like Jupyter Notebook, so we'll deploy it as well. We can deploy those components to the cluster in a few steps. First, download and extract the latest version of Bigtop Turbo and run a script into Puppet on each node. Then rewrite the configuration file to specify installation settings, such as which software to install or which parameter to override. It looks like complicated, but it just defines 4 parameters to be set or overridden in the site.yaml file. FQDN for the head node, local directory path for storing HDFS data, components to be installed, and enabling the Big Pet Store DAG. The first 3 parameters are required for any cluster, and the last one is needed to install the Big Pet Store DAG. Then we distribute that configuration file to all nodes in the cluster, copy all related files to the dedicated directory, and run the Puppet apply command on each node. Once the manifest is applied, Puppet detects difference between the current state and the desired state defined in the configuration file. Then it runs package installation, user creation, and so on to fill that gap, just like a reconciliation loop of Kubernetes. Installation process will be finished within a few minutes, and then we get a new cluster in accordance with the configuration file. Once deployment is finished, we can access Airflow's web UI on port 8080 of the head node. Unfortunately, our Airflow version is 2.10, so it looks old-fashioned. But anyway, we can log in with admin for username and password. In the same way, we can access the web UI of Hadoop name node on port 50070 and Zeppelin on port 9080. At the time of Bigtop 3.5, a few additional steps are needed to run the Big Pet Store DAG. We need to build Big Pet Store jar file on our own and create Airflow's home directory on HDFS to run Spark job as the Airflow user. But these steps will be automated in future releases. After logging in to Airflow's web UI, we can find the Big Pet Store DAG in the DAG's view. Then we can trigger the DAG. The path to the jar file of Big Pet Store is parameterized, so we can specify it before running it. If the settings are correct, the DAG is supposed to be successful, just like this screenshot. And when the DAG is finished, we can see the original generated data and the transformed data into normalized form on HDFS through name node's web UI. And we can see the results of the analytics task from Zeppelin. The results of analytics is output as a JSON file on the local file system of the head node. So this short script reads the statistics in that JSON file and shows the number of transactions per month as a table or chart. And here's the result of a machine learning task. The recommendation results is output as a JSON file as well. So the top results are shown here. For example, product ID 202 and 193 and so on are recommended to the customer 0. Here's the conclusion of this presentation. Bigtop is an ASF project that offers software distribution for big data processing. Recently, Bigtop incorporated Airflow as its new workflow orchestrator, so users can easily build their own data platform, including Airflow. Bigtop consists of various ASF projects such as Hadoop, Spark, Flink, and Kafka. And Airflow perfectly works as a keystone of those integrations. We currently just have a single example DAG of such an integration, that is Big Pet Store, but we'll add more diverse workloads such as streaming, GenAI, and so on to give users reference use cases. Thank you so much for attention.